The role of artificial intelligence in automotive technology. Title: The role of artificial intelligence in automotive technology. Introduction. In recent years, the automotive industry has witnessed significant technological advancements that have revolutionized the way we travel. One of the most impactful innovations in this industry is the integration of artificial intelligence, AI, into automotive technology. AI's role in automotive technology has not only enhanced the driving experience but has also paved the way for safer, more efficient, and increasingly autonomous vehicles. This article explores the various ways AI has transformed automotive technology, showcasing its potential and future implications for the industry. 1. Autonomous driving. Artificial intelligence plays a crucial role in the development of self-driving cars. Autonomous vehicles leverage AI algorithms and sensors to perceive their surroundings, make real-time decisions, and navigate safely. AI-powered autonomous driving systems rely on technologies such as computer vision, machine learning, and deep learning to interpret road conditions, detect objects, and respond accordingly. These systems continually learn and adapt to different driving scenarios, assisting drivers and providing an extra layer of safety on the road. 2. Advanced Driver Assistance Systems, ADAS. Artificial intelligence has greatly contributed to the advancement of driver assistance technologies. ADAS features, such as adaptive cruise control, lane keeping assist, and collision warning system, rely heavily on AI algorithms to improve vehicle safety. Through data analysis and machine learning, these systems can identify potential dangers, alert drivers, and even take evasive actions if necessary. AI-powered ADAS technologies act as a guardian angel, enhancing driver awareness and reducing the risk of accidents. Artificial intelligence, specifically natural language processing, has made interacting with these systems easier and more intuitive. Voice recognition technology, powered by AI, allows drivers to control various functions, such as navigation, calling, and music, simply by speaking commands. NLP enables these systems to understand and interpret human language, which ultimately contributes to a more seamless and safe driving experience. 4. Predictive maintenance. AI has also revolutionized automotive maintenance practices. By analyzing data from various sensors, AI algorithms can predict and detect potential issues in a vehicle's components before they become critical. This predictive maintenance approach helps reduce vehicle downtime and ensures optimal performance. 5. Traffic management and optimization. As urban areas become more congested, efficient traffic management becomes crucial. AI plays a significant role in optimizing traffic flow and reducing congestion. Integration of AI into traffic management systems allows for dynamic adjustments of traffic signals, reducing traffic jams and improving overall efficiency on the roads. 6. Enhanced cybersecurity. With the increasing connectivity of vehicles, the importance of cybersecurity cannot be overstated. AI plays a vital role in automotive cybersecurity, protecting vehicles and their connected systems from cyber threats. Machine learning algorithms can detect anomalies in vehicle behavior, identify potential hacks, and promptly respond to security breaches. AI-backed cybersecurity measures ensure that vehicles remain protected and drivers' personal information remains secure. 7. Intelligent transportation systems. Artificial intelligence has also been instrumental in the development of intelligent transportation systems, ITS. These systems utilize AI algorithms to optimize traffic management, improve transportation efficiency, and enhance overall mobility. Through real-time data analysis and predictive modeling, AI can identify traffic patterns, congestion hotspots, and provide alternative routes for There. It's powered by I can also integrate with public transportation systems, enabling seamless coordination and enhancing the overall transportation experience for commuters. 8. Enhanced driver personalization. Another area where I has made significant contributions is driver personalization. AI-powered systems can collect data on driving behaviors, preferences, and habits to create a personalized driving experience. This includes adjusting seat positions, climate control, and even music preferences based on the individual driver's preferences. With AI, automotive technology can adapt to the driver's needs, providing a customized and comfortable driving experience. 9. Vehicle-to-vehicle communication. AI enables vehicles to communicate with each other through vehicle-to-vehicle (V2V) communication. By exchanging real-time data, such as speed, position, and intentions, vehicles can cooperate and make collective decisions to enhance safety and efficiency on the road. V2V communication, facilitated by AI algorithms, can reduce the risk of accidents, improve traffic flow, and enable smoother lane changes and merging. 10. Data-driven business insights. AI has also transformed the automotive industry by providing valuable business insights through data analysis. With the integration of AI algorithms, automakers can analyze large volumes of data related to customer preferences, market trends, and vehicle performance. These insights help in making informed decisions about product development, marketing strategies, and future innovations. AI power and analytics enable automakers to stay competitive and responsive to market demands. 11. Environmental impact reduction. The use of AI in automotive technology has also contributed to reducing the environmental impact of vehicles. AI algorithms help optimize engine efficiency, reduce fuel consumption, and minimize emissions. Science. With AI, vehicles can adapt to different driving conditions, optimizing energy consumption and reducing the overall carbon footprint. Additionally, AI algorithms can contribute to the development of electric and hybrid vehicles, promoting sustainability and a greener future. 12. Infrastructure planning and maintenance. AI algorithms can also assist in infrastructure planning and maintenance. AI-powered systems provide valuable insights that can aid in the effective management and maintenance of transportation infrastructure. With its ability to analyze data, make real-time decisions, and enhance safety, artificial intelligence, AI, has become an integral part of automotive technology. One area where AI has had a significant impact is in autonomous driving. Through the use of AI algorithms and sensors, self-driving cars are able to perceive their surroundings and navigate safely. AI-powered systems, such as those used in computer vision and machine learning, can interpret road conditions, detect objects, and adapt to different driving scenarios. These technologies provide an extra layer of safety on the road and assist drivers in reaching their destinations securely. AI has also played a crucial role in the development of advanced driver assistance systems, ADAS. These systems, which include features like adaptive cruise control and collision warning systems, rely on AI algorithms to improve vehicle safety. By analyzing data and using machine learning, ADAS technologies can identify potential dangers and alert drivers, reducing the risk of accidents. With the help of AI, these systems act as a guardian angel, enhancing driver awareness and improving overall road safety. Furthermore, AI has revolutionized in-vehicle infotainment systems and made them more intuitive. Natural language processing, NLP, a branch of AI, allows drivers to interact with these systems using voice commands. Through AI-powered voice recognition technology, drivers can control various functions such as navigation, phone calls, and music with ease. NLP enables these systems to understand human language and contribute to a more seamless and safer driving experience.